cruise that went to the Musicians Seamounts just recently. And Mike, if you wouldn't mind talking us through what we're looking at today.
Sure. So we had a short but looked like wonderful dive yesterday on the Musicians Seamount, down here where my cursor is. We then transited overnight. We edge matched the EX 1707 data collected on Brahms Seamount to the west here, and then transited up to here on Wagner Seamount, where our dive will be today. And for everybody's reference, our dive tomorrow will be on Verde Seamount to the northwest here. Two things, and I want to start with this view, and maybe John, you can chime in. This seamount's a little different than the ones we've been diving on, because it looks like not only is it within proximity to some other seamounts, but it also looks like it may be in a more complex geologic setting. Maybe on some ridge lineaments. Maybe the seamount has a couple of different things going on here. Do you want to say a few comments, or folks on the line? Tom, Eric?
I'll just throw in, yeah, I agree, Mike. It's we're kind of getting into these lineaments, and so we could have a combination of things going on, and a combination of morphologies, whether or not we'll see it on this dive, but there could be combinations of chemistries. Maybe I'll throw it over to Eric, because he and his group are actively researching these features.
Great.
Yeah, this is Eric Middlestead from the University of Idaho. These kind of lineaments are commonly associated with interaction of hot upwelling mantle deep in the earth that causes the formation of these seamounts. And when that hot upwelling mantle, which is known as a mantle plume, happens to be near mid-ocean ridge, we often see these kind of linear extensions of volcanic features that we call lineaments. One of the more well-known areas where we see this is in the Galapagos, and the chemistry and kind of form of these seamounts is currently being investigated and is debated about whether it's kind of controlled by stresses in the lithosphere or some other feature like melt transport, so transport of molten rock underneath the crust. And these lineaments we're at today, so Wagner and Verde Seamounts are part of these lineaments, are interesting parallels to what's going on in the Galapagos, and hopefully we'll get some information today and the next few dives that will help us illuminate what is kind of behind forming these lineaments.
Excellent, thank you. So for folks following along on shore on feed 3, we've zoomed into our dive today. And I just want to stop here. We're on this sort of cone cluster, and we're actually going to be diving on the northernmost cone. And my guess is that these cone clusters are likely some sort of secondary volcanism on top of this ridge feature. And today's dive, we're going to be starting at a depth of around 2,518 meters, and then we're going to do pretty much a straight transit, perpendicular across contour lines in red here to the top of the cone, reaching a depth of 2,275 meters. We did keep this depth, we did keep this dive relatively short, so we would have plenty of time to spend on top. Looks like we're already being rewarded with a fish and an anemone. So, Megan, maybe this is a great time to pause and we can talk about the biology on the screen and the biology we expect to see today.
That's great, Mike. Yeah, so we are seeing a fish, and I think I'll let Bruce take this one away.
Okay, well, this is an unusual one. It's a cusk eel in the family Ophidiidae. However, we've seen this 2 or 3 times before in the past 3 years on the Okeanos Explorer expedition. And when we sent pictures off to an expert on this group, Dr. Shinpei Ohashi in Japan, he replied that he's not sure what this is, but he thinks it could be an undescribed genus and species of cusk eel. It's got a rather small, rounded head in relation to the body. The body is thickest about halfway back on the fish's length, rather than just behind the head, as it is in a lot of these fishes. And this has a sort of peculiar ridge going along the side of the head underneath the eye, above the mouth and back toward the gill cover. That's fairly distinctive. It's got a very unusual appearance if you're familiar with these cusk eels. So this is quite an unusual observation. And we don't know what this is. It could be, not saying that it actually is, but it could be something that has yet to be described. I'm also seeing then a number of invertebrates, interesting invertebrates in this area.
It's the slope.
Thanks for that, Bruce. Yeah, when we first landed, I saw Relicanthus. That's that anemone-looking creature that we saw, but it's actually not an anemone. And then right now we're seeing some Anthomastus corals. Those are soft corals right there underneath our Castile. Their common name is mushroom coral because when the polyps close up, it kind of looks like a little Mario mushroom.
Does it allow you to grow?
I would hope so.
Good.
But I haven't eaten one yet. We do have 4 in the lab, but they have been preserved in formalin and ethanol. Maybe the ethanol one would be tasty?
All right, let's come in on that mushroom coral in the middle. Actually, still have the fish floating around.
And then next to our Anthomastus are some hydroids, and the fish is photobombing us. Really wants its close-up.
All right, going back.
And it looks like we're seeing I'm not sure. Maybe possibly a tube anemone coming out of an old sponge stalk, or possibly a polychaete worm that has made its home inside this sponge stalk. So you see a little bit of a tube coming out of the stalk.
All right, pilots, so
Do we have any more zoom?
they're hoping to just make our way up the slope here. It's about 470 meters. We have about 5 hours and 20 minutes of auto
That would
time.
be the zoom.
The zoom.
The
So
extra
we need
zoom.
an average 0.05
Bonus
knots,
zoom.
so we should be moving a quarter
So it's
of the
really
time,
great that
0.2.
our ROV is
So pretty
equipped with
normal.
this
They wanna
really
get to the
high
top a little bit early to
definition
have some time to look
camera.
around at the end of
Allows
the
us
day,
to get
so
amazing imagery of very small animals.
standard.
And in the background, I'm seeing an octocoral, possibly a chrysogorgid.
Forgot we had the zoom enabled. That's better.
So it looks like the tentacles of this animal are pinnate, meaning that it has lots of other projections coming off the main tentacle. So it's making me think this might be a polychaete. Does anybody on the chat or on the line have an opinion about this animal?
I was thinking it might be a sabellid or something like that.
Any more zoom video?
Yeah, polychaete.
Okay.
Yeah, Bruce, now that I'm seeing it closer, I think you're right. But to identify a polychaete, it's usually best to have a specimen in hand. Very cool.
Yeah, Megan, that wasn't Bruce, so you're going to have
Oh.
trouble keeping track of the voices on this side.
Oh, sorry. It almost sounded like you. My apologies.
Okay, video whenever you're happy with that. All right, co-pilots.
You can tell when I speak because it's all about the fishes.
All about the fishes.
Fly around.
Well, you did chime in
Got some
about that
lasers.
one worm the other
So
day, right?
Before we
The green
get too
bomber.
focused here, so just so you guys are aware,
Yeah, I do
the wind
sometimes,
is
you're right.
hanging around 18 to 20 knots coming out of 030, which is roughly where we're pointing.
So the other day we saw a
That will be
swimming
the dominant
polychaete
force,
that
but I
has
expect,
these
you know,
two
if we were to lose ship
organs
propulsion,
on the front
Probably
of its
our heading
head
would turn.
that it might drop
I
if
expect
it
we'd end
finds
up
a
drifting more or less
predator.
south, kind of
And
laterally along.
it has this
this slope.
bioluminescence in
So
it that'll allow
if that were to happen,
the
what
polychaete
would be
to
the game plan
escape
here?
while the
If the ship were to
predator is
lose
distracted
propulsion,
by the bioluminescent
South and
bombs.
swing around.
Yeah.
Clockwise.
It was a highlight video,
Space,
so
what
please
would you
do check it out.
Let's say we lost propulsion right now.
One second.
Turn right,
watch
haul
it.
in.
So also in this area,
Let's
I'm
say
seeing some
come up-
crinoids
Come
and
up,
an enemy.
well off the bottom as fast as you can before you start feeling that move.
And I think
you
there
would
might be
swing
some
ar- D2 would
interest
swing
in
around to starboard.
collecting a rock in this area.
Seriously.
I've been
back to
talking with
starboard.
Eric on the
Get into tow.
chat, and we're going
Pointing
to wait a
south.
little
Yeah.
while.
So
Okay.
Try to
I
find
just
something
head
more
out.
ideal, but there are plenty of
Yep.
rocks to be chosen here.
And our bailout right now is due
Trying
east.
to find something
so,
more in place.
You know,
That's a bit of a tall order.
if anything
but
were
we
to
will
happen
try.
where we'd need to do the bailout, just be prepared for that.
I appreciate the effort.
No problem. It's just a game of
Yep.
waiting and
If you have control.
What's the highest,
waiting
point?
until
The highest point is
Possibly run out of
2270.
options.
So if we were to pull up on the winch
we'll see.
at full 30 to 32 meters per minute,
Sounds
it
good.
would take about 7 or 8 minutes to get above the feature.
Okay.
Okay.
The depth.
All right, watch this. Sorry, back with you. What would we like to look at next?
So is there a plan for this area? I think we're going to wait for a moment, pilot, on our sample collection. Let's look around and see if there's any more interesting biology in this area before we leave.
Okay.
Yeah, pilots, just to pass on that we'd like to try to find some kind of rock that's as in place as possible that we can still get, something like a toe of a lava flow that's separated by a crack or something like that.
Okay.
So if you
So this has all fallen down, and you're more interested in something.
right, something that we know that it
Understood.
probably came from that location.
Sure. Video, let's come in on this. See what it is.
So we've got about a 5-minute
Yes,
delay.
Eric,
You're
to clarify
looking
just a little
down
bit, what we're looking for is
43
something
degrees.
that's part of a lava flow that's obviously in the
We
location.
could call in a
it,
move and
hopefully originally erupted, and a lot of what
push
we're
out
seeing
when we're
around
done
here
here.
is a lot of loose
What do you think?
boulders, and so they probably came up from higher
43.
up the little cone we're on,
20 meters.
and it's hard to determine the provenance or where those rocks
Do
came
20?
from. They're just kind of sitting loose.
Did Watchley say they were looking for rock in this particular area?
So
Not
right
right
now
now.
we're looking at a black
Yeah, no,
coral,
I'm okay with that.
Okay.
and in
What
the
bearing do
middle
you
you're
want?
seeing some
250.
really fuzzy polyps. I think those might be reproductive in nature.
Can we kill lasers?
Sure. Video, if you come out, I'll get in closer to this and sit down.
Put lasers back on just so I have a reference.
So I'm seeing a lot of different sized rocks in this area, John. Is this a lot of talus and large boulders, or is some of this in place?
I think these all look, what we're looking at right in the main screen is all boulders that have tumbled down or slid down the slope from lava flows
Here's
from
video
above.
back in.
So they, over time, hundreds, thousands, millions of years, these lava flows will break up from just physical weathering, physical processes, earthquakes, landslides, and then while the Seamount was an active volcano, you have all kinds of eruptive activities going on that generate tremor and all kinds of things. So just boulders of various sizes, we call it talus or scree, broken up rock from the features above. You can see this on land in many places, like in rock quarries or at the base of mountains, at fault lines, piles of rock of angular shape, usually in this case. So kind of jagged stuff where it's broken away.
So on this coral, I'm seeing an associate, a small round disc. I'm not sure what that is.
Is this full video?
It looks like a
Watch
clam.
like this is now.
A clam?
It could be a Montecudid or a Lysaid type clam, some kind of symbiotic clam.
That's really interesting. So it looks like it's attached, but maybe by some sort of basalia to hold on to the coral. So little threads that come out of the clam.
I'm not sure. Yeah.
Bridge,
Some
this is
type
now.
of
Nice shot,
attachment that the clam produces.
Go ahead now.
Yeah, we'd like to
That's
request a
very
ship move,
interesting.
please.
Okay.
We'd like a move of 20 meters, bearing 250
There's
at
several
0.2
families of
knots.
these small
20 meters bearing 250,
symbiotic
speed
clams.
decimal 2.
That's correct.
All right. I think we're happy with this.
All right, should we move on?
I think we should move on.
Come on up.
Thank you,
All
pilot.
right, watch lead. We've got a ship move underway. Just a short hop.
Okay.
Are we looking to get a rock right away here, or do we want to?
Not from
quite yet.
from this location.
Okay.
Looking
RV
for,
nav bridge move initiated.
something
Next
where
bridge.
you didn't fall down the slope.
Yeah, we'll keep moving up slope then.
Any interest in this coral on the back?
It looks like there's another black coral on this boulder.
I'm going to range it down on sonar, co-pilot.
It's definitely a
Bring it down to
different
50.
species of black coral.
Bring D2 down to, let's
Video
try
coming.
30.
So we'll just wait a moment so we can get a nice zoom on this coral before I attempt an identification here.
Come in, video.
All right, Sirius at 50 meters, D2 at 20 meters.
Wow, looks great.
So this to me looks like Stauropathes, a type of black coral. You'll see that it has these side branches that are also branching. And that's pretty typical of Stauropathes.
Hi, Megan. It's Chris. I would agree with that. And I'm not on the chat right now, but that first one looked to me like it could be some kind of heteropathes. What do you think?
I'm not sure about heteropathes. I'm looking at the heteropathes right now. It reminds me more of Stauropathes. Maybe Tina
Video and
will have an opinion about this
This
later.
one is Stauropathes. I would agree with that. But that other one,
Oh yes, the other one,
Might
yeah, I
have been
think is
heteropathes.
heteropathes.
that orange area right in the center.
Yeah, we saw a couple of those, I think, before, and it does look quite heteropathes-like to me. They tend to have that, reproductive polyps located along that main axis of the coral. And there's another coral hiding around the corner of this rock.
Oh, there is.
Down in the shadow.
So even at first glance, it didn't look like there was a lot of life down here, but every time we move, I'm seeing something different.
Yeah, and you ask about lava flows in place. I think this one in the center is probably looks like an in-place
It's in the shadow
pillared
video.
flow.
Let's try it.
The one kind of bulbous looking next to the big boulder of about the same size. Is this the bubblegum coral?
Right now.
Yeah, I'm trying to decide if it's a bubblegum coral or a pink coral. It looks more pink coral-like to me, but I can see where you'd think it might be bubblegum based on the cluster of polyps at the end of the branches.
There's some polyps that are not closed up on the bottom. Any more zoom video?
Good shot of the manganese crust here on these rocks. This botryoidal texture, which
Tried
is
moving the light, but I don't know if it
Greek
helped
word
at all.
for grapey. So it looks like a bunch of small grapes clustered about. So this material precipitates out of the seawater at a very slow rate, millimeters per million years.
So why does it have that texture?
I don't actually know why it grows that texture. It's a good question, but it does. It's a common indicator of that crust.
You like
And the crust is made up of all kinds
just
of
started
metal,
moving, yeah.
metals
Okay.
and elements,
Maybe
manganese,
Maybe a
iron,
4-minute delay or so.
Yeah.
cobalt in it. I guess it has rare earth elements in it. So it's a potential product for deep
Ship
sea
was
mining
called
down the
my
road.
heading pilot as per.
So what makes this type of crust so valuable to deep sea mining? And how would you collect a crust on such a large boulder? Are you just going to scrape up talus that's been covered, or you want to try to gather stuff that's in place?
Well, the materials that it's made up of are things that we use in our modern life for cell phones, solar panels, airplane wings, car parts, whatever. So there's a limited amount of that stuff on land, and that's not always easily accessible because it may belong to maybe found in other countries. So the deep sea has that's a big resource. Getting it, that's the big question. How would you get it? You'd have to grind it off or chomp it up somehow, so that could be rather destructive. This is a good example of a geological contact here. We're transition between two different units, two different rock types or morphologies. So we're transitioning into a more intact lava flow unit. So this looks like it's a kind of a flow unit that's maybe I don't know, less than a meter thick, but mostly pillowed. As you can see on the top, these bulbous forms are moving down slope. So the underwater eruptions erupt kind of in this toothpaste style of lava flowing out, effusing and creeping down slope. And then it's breaking away here. You can see this blocky pattern in the front and creates all this talus or broken rock that moves further down slope on its own. And then in between of all this light-colored material is this sediment that rains down from above.
Okay, that's good.
Hey, this is Eric at CMEL. I think this would be a great place to try and grab a sample, see if we can't break off one of those little buds.
Should just have another minute or two swing. Co-pilot.
Okay, Eric, do you see any
pointing to move, right?
in particular? So actually moving up on the flow unit or on the edge here is what are you thinking?
Well, it would depend on what I know that the arm, I think, has a strength limit of 200 pounds, John said. So it'll depend. I think we should look for kind of a bud that looks like it's sticking out pretty far and maybe is already fractured. Maybe if we look around a little bit. Some of these ones we're looking at in the screen right now seem like they'd be a hard sell to pry loose. But this whole feature, as you were pointing out,
Going tight on this one.
pretty massive and in place. So anywhere we can break something off would be a good spot, I think.
Okay, so it sounds like you want us to move up onto the flow itself and look for something.
Yeah, that might work.
Okay.
How close was it? Come out video. I'll look for that black coral.
Right behind it.
Oh, is that it? That whip? Oh, I see it. Yes. A little far away. Let's try
So I'm
from here.
seeing another type of
Come on
black
in.
coral here on a long stalk.
I think we're too far.
So I think this might be Alternatipathes, a type of black coral that has a very feather-like shape, but a long stalk. And along the stem, you can see a line of polyps, and on each one of the branches, there are lines of polyps. So it's similar to the Heteropathes we were looking at, but this is a different species. Thank you, pilot.
All right, come on out. And was there a potential for a rock along this edge?
So, Pilot, the deal with the rock is they want to be able to break something off.
Right.
Of course, right here it looks like that wouldn't be possible. And I know you prefer to be able to grab something that's relatively loose, or we can ram it with the skids to see if it'll break, but I don't think that'll happen here.
Yeah, ideally we're looking at something that's cracked already, of course. So the onshore geologists asked if we probably move up onto the flow when ready with the ship move and see what we can find.
All right.
So how thick would the manganese crust be around here? I know it takes a long time to precipitate. Based on what you think the age
so it looks
is
pretty
here, would
encrusted.
that be really thick or relatively thin?
I guess kind of moderate, maybe. I suppose maybe
Do you want to turn
I don't
lasers
know,
on?
centimeters or so
Yeah, let's do that.
They're just coming on.
in some places. Though I know we've seen some thinner ones, and it kind of depends if you
Yeah,
have
the
a
sheet
rock
right
that's
here
broken
on their port side
loose
there.
later and the surfaces are fresh. You know, many millions of years later, the crust is going to be much
blanket.
thinner on those
Very hard.
faces. So
Yeah, if you look along the edge of that.
for
there
the
might
stuff
be
that's in
something.
place, like you know, these lava flows we're looking at now, it's going to be at its thickest.
So this looks like a different type of flow, more sheet-like.
Right, it does. Good eye.
I'm getting to know my rocks.
All right, I can come up onto it. And,
What about that one on the just under the coral there?
So you might get these sheets
Kind of 4
with
o'clock on the lasers.
steeper slope and or a higher effusive rate or a higher eruption rate of more lava per unit
it may have
time.
fallen down from above.
So it comes out fast and flows faster before it gets chilled and quenched by the water. So it makes a smoother surface as opposed to the pillowed, more bulbous forms that kind of creep along slower.
These
It's a really nice example of a sheet flow.
the lasers on are
Don't normally you don't see
probably
these
not
all the
interesting.
time because you have to have the right conditions for them.
Well, Watchley, would you like to spend a couple minutes searching for something we might be able to crack off, or do you want to continue upslope?
Yeah, let's go ahead and search here for a little bit
Okay.
Okay.
if you're in a good position to do so.
I would. Yeah. Let's just start.
What about, there's a coral on this sort of rock and a crack right on the left side of the screen.
Oh, yes.
That's sort of
Yeah,
interesting.
kind of look at the coral. There might be some.
Let's
maybe
let's
something
take a
crack
snap
off on the
zoom
left
of the
side
coral.
later.
It might give us a good view of what might be here in this cracked area.
All right, let's come in on this coral.
See, I used geology to my advantage to look at a coral.
that was pretty sneaky.
Oh, there's a sponge there too.
Don't distract us.
So this also looks like a pink coral. And there's like a overgrowth right in one of these branches. Maybe something disturbed it there, or it had something attack it and it overgrew. And then I'm seeing a stalk sponge, possibly a bolosoma, which is a glass sponge,
Bridges
poking
is
out
now.
on the side of this rock. And another coral.
Yeah, I see the
Chrysogogic
ship's
coral?
position is drifting a little bit.
Just
right
above
back.
that.
Are you having a hard time holding position?
Yeah, unfortunately, I think this
How
rock
are
is
things
a
looking up
piece
there?
of talus
Things
is
are
tumbled
looking
down
all right.
and wedged
I
into this
noticed
crack.
that as well. It tells us like how
Well,
many
it's got nice biology.
go off of our intended
Yes, it does. I wonder if that brought
Yeah.
that down from above.
I wonder, but you'd think that something that fragile, those hemicorallium corals are quite fragile. They would
Yeah,
snap off.
I don't think it would have survived. That's why,
Okay, but
why
you are
it's
seeing
younger
that
here.
drifting on the
But it's-
CP system.
It
up
is.
there.
Yes, I am.
Yeah, interesting
Okay.
place. It's
Keep
kind
an
of
eye out,
sideways.
thanks.
Okay, we'll do.
Yeah, it's sort of sideways, but maybe that crack is increasing flow.
For center rotation.
Or
the crack, you can see this
It is
piece
safer,
that
I guess.
looks like it's broken off. It's probably, it may be sliding down and rotating the piece of talus. So that's a nice example of like a calving glacier, a big chunk of it breaking off of the flow, moving downslope.
And we had a couple rocks over here that bring the lasers back to. Are those also likely from above this grouping?
So all of this seems pretty in place. That's the hard thing about rocks. You have to be able to gather them, but you also want one that hasn't been disturbed.
Yeah, I'm not seeing much here. Watch lead.
This is Eric. What about the bud that's kind of in the bottom of the screen right now? I don't know how much my delay is. It's moving to the left.
Why don't we put another 20-meter hop and
Just is leading the screen right now.
Sure.
We can take a look. Not sure which one you're...
So it looks kind of like a little bud sticking out. I don't know if you can tell which one I'm talking about.
Oh, it's kind of a...
Bottom left of the lasers.
A darker black nub.
Yes, yeah.
Yeah, right by the pilot, right above the lasers now. There's a nub there. I don't know if we could take a look at possibilities of getting that.
Look at it.
Look at it. That looks
Well,
pretty
this area,
crusted,
the
yeah.
lower left side, looks kind of cracked. Do you think those might be loose?
Well, I think he's wanting to actually break this off, which I don't know if that's going to work, but we can take a look.
Yeah, I mean, something like this, if we're going to be able to do it, would be kind of ideal because it's kind of sticking out, so it might be easier to break off. Now, I don't know how much of this, how easy it's going to be with the crust.
Yeah, that stuff is pretty tough. The bigger rock may actually be, it's probably welded. It's possible it's cracked, but it might be too big. I don't know. We can
come back out. Which bigger rock?
Well, it's attached. It's the same one. It's just attached.
Oh,
that nub is attached to a bigger piece, of course, and that there looks to be a crack around it. So I was wondering if that was possible.
Yeah, I don't know if you guys are willing to give that a shot, or if you already, through experience, know that's not going to work.
Well, I don't know. I feel like we can try.
I don't think it's going to move.
Looks pretty solid.
Yeah, that'd be great if you guys are willing to give it a shot.
Nope. That is pretty well stuck.
Yeah, the usual procedure is we bump it with the ROV. It's got a little more oomph, and see what happens.
It looked like it was pretty stuck. Nothing happened.
What about this coming into the middle of the screen, this piece that looks like it's separated from the flow above, that crack
like 10 o'clock from the lasers?
To the left of that crinoid or whatever it is. But
Yeah, about 10 o'clock.
yeah. Now that to me looks like those two rocks actually look like they're just cracked but separated.
This one?
Yeah, that one. What do you think about that, Eric?
Yeah, I would agree. That's what that looks like.
It looks like it's attached.
You can see the one right below it is cracked and still
Just
even
give
more
them
in
a
place,
complete.
but probably easier to get the... Well, I'll leave it up to the pilots, I think, whichever one they think they can grab.
We're going to see if it moves.
I think the left side's pretty well attached, yeah.
Yeah, try that one below it. I know it's pretty big, but...
Oh,
Nope.
yeah.
It does
It
move.
looks pretty
little
big.
vibration.
When do we get a size estimate?
Sure.
Looks like a pretty large rock. So the lasers that you're seeing on the screen are 4 inches apart, 10
Depends how
centimeters.
thick it is. If it's super thick.
That's about a foot long.
That's going to be a heavy rock.
That's going to be big.
We've got an intern aboard. What's that?
It depends on how thick this is. If it's a nice thin piece,
Yeah.
you can do it. If it's thick, I'm not sure.
Well, there's the one to the right, which is a bit smaller.
I don't think that one moved.
Give it a poke.
Oh.
Did we bump it? I didn't see it.
We did bump it.
We'll give this one a try.
Okay, we're going to give this one a try, see how big it is.
It did seem to move when I bumped it.
We are limited also on how much weight we can bring aboard. So
Yeah, we want the ROV to
Hydraulics
be
are
able to
go,
come to the
pilot.
surface without use of the thrusters if we do lose power. So the ROV is neutrally buoyant, or no, it's positively buoyant, so that if we do lose power or for some reason the line does get cut from the ship, it will float to the surface and we can recover it. So we don't want it to be neutrally
Toss it to
buoyant or
starboard.
sinking
Get it?
negatively buoyant.
Yeah, I think that's the starboard one.
Copy. Give it a poke. See what we got.
So all the time while we're exploring the seafloor, the thrusters are thrusting us down to
Yep,
keep us
that's
down
correct.
here.
Great.
then take a look and see if we can get this and see how big it is, how thick it is. Basically, is what that will depend on.
Okay. No, I would.
Sounds good.
I'll let you do your thing.
Okay. And arm out.
When you're, yeah, jaw closed exactly.
Yep. Just gonna pick this up a little bit. See how it feels. It's heavy.
Or be now, Bridge.
Go bridge.
I would like to adjust my heading about 5 degrees to port just to keep the wind on the bow.
5 degrees to port is fine.
Thank you.
So do you think I should try to get it here or try to go in under the edge? I think I can get my fingers in this way.
Yeah, that'd be
Try that.
worth a try.
Did it just crack off?
The manganese crust is coming off a little bit. Actually, I might be able to get a better grip now.
There you go. Now it might be in a position now where you can really get the fingers around it.
Yeah. I think I moved it out a little bit. Make sure I'm still stable here.
Yeah. You can see your left toe kind of drifting off a little bit. Yeah, it's holding. Auto head.
I have auto heading.
Yep.
So bring it down a little bit. A couple more degrees.
Adjusting any Zeus. Yeah, maybe try to get the fingers under it, maybe. Watch the coral cutters.
Yes. Maybe I'll try.
Also come in from the right side, yeah.
I'm gonna give that a shot.
bring wing in a little bit or leave it? Starboard wing.
Yeah.
Okay.
Come in on starboard wing.
Going in.
Well, John, how does that rock look to you?
Wings all the way in.
Looks good. I think
Let me rotate up.
unless
for you.
Eric says something different, I think that we'll keep that unless you think it's going to hinder us from collecting further as far as it being too heavy. Looks similar to ones we've collected before.
I think it's fine.
I think it's right on the
Derek,
border.
I can't
It's,
comment on the weight, but this
it's
looks like a nice grab.
At the limit,
Thanks.
but I think it's all right.
Yeah, so Eric's okay. I think we'll keep that one.
Okay. Put it in the box.
I'm not carrying it. I'm just saying that right now. That looks quite
Bring Mrs.
formidable.
over. See your wrist.
That's helpful. Yeah, wrist.
It's a beast.
yeah, so your elbow's all the way tucked in already.
Yes. Bring that up a little and do this with the wrist.
Very nice.
See how it is. You're going to try to make that rock box nice and full.
Slide it right in
But
there.
I know you will be trying to pick stuff off it, living things.
Yep. Hopefully there's something good on that rack.
Looks like you're pressing the box in the front.
I am. I'm trying to.
Yesterday's rocks had quite a
Just go
number
drop
of
it in, so
different
you don't accidentally
organisms
press
living
down
on
the
them.
wing while it's deployed.
Dropping it.
There you go.
Sick operation.
Wow, that was a perfect fit.
All right, pilots, great job. And we are fortunate. We landed by the
Bring the
sheet
wing
flow,
outboard.
so it was good opportunity to get something that's we know is in place. Can't get much better than that. And that was already cracked loose for us. Even.
Z-bias after that.
Yes, I will. Can you help me?
Yeah, that was great.
Yeah,
Thanks
sure.
a lot.
Twist it up here.
Pretty close to my mini Zeus. I want to swing outboard a little bit.
Okay. Now,
Thank you.
that's better.
Great. Cool.
Okay. Draw this off.
Nice job, Dave.
Thank you. And I'm already going to adjust the Z-bias. I think that's a 4% rock. Let's see how that goes.
Mini Zeus back to you. It's centered up.
Thank you.
Swing arms still deployed. Take my monitor back. Catch you at 52, so you could move a little bit. We could probably call on a move, I bet.
Yeah, let's go ahead and do the 20 meters.
Yeah, at least, man.
250.
250.
All right.
All right, one
Bridge is
collection
now-
done.
It's a 3% rock. That's pretty good.
Go ahead, Matt.
Yeah, we'd like to request a move.
All right.
20 meters, bearing 250 at 0.2 knots.
Let's see, let's
20
see.
meters, bearing
What do we
250,
got here
That's
in
correct.
terms of biology?
Well, like many of our dives, it looks a little sparse at the beginning, though yesterday was a complete change to that. We had dropped into a high-density community halfway up the slope because of our shortened dive, but it never stopped. So just stay tuned. I'm
RV
sure
Map
we'll be
Bridge,
seeing
move
more
of 20
biology
meters,
as we
250.
move up the slope.
Thanks, Bridge.
So right now we're at a depth of 2,410 meters. We're seeing a lot of diversity in terms of black corals. So now we're seeing another heteropathies that we saw earlier with those dense polyps centered along the main axis of the coral. Those are likely reproductive in nature. We saw some stauropathies, ultranautipathies. So this might be a good depth range for black corals.
So this is this isn't the same one we saw before.
Well,
but it's got
it was one of the first ones that we zoomed in on was this one on the side of that rock,
right.
and then behind it was a different one, and behind that was another coral, a pink coral.
Okay, video. Let's move on. Do we have a move in now?
Sirius won't feel it for another 2 minutes or so, but yes.
So I'm seeing another Stauropathes, that brown yellow coral fan up in the top right. And another Heteropathes passing to the lower side, end of the screen near the bottom. And two contrasting geological morphologies right here. These sort of lobular area and more of a flat area.
Yeah, it's a nice view of this. The sheet flows in the back, and these it looks like a mix of some in-place pillow flow outcrops, and then a lot of rubble or broken pieces mixed in between. So it's a really nice contact or transition between two morphologies. Same type of rock, though. Should be the same chemistry.
Zoom on this.
Right now we're zooming on a crinoid. And then right below it I'm seeing a xenophyophore. So this looks to be like an atelocrinid. And then the xenophyophore is this sort of crinkly looking organism on the rock. It's actually a single cellular organism, like an amoeba, that creates this outer test or crusty outside structure. You know, crusty on the outside, squishy on the inside.
That's the way we like it.
And in the background, we're seeing a single polyp of a baby octocoral. Just one polyp, all on its lonesome.
RV nav bridge, move complete.
Thanks, Bridge.
You can identify octocorals based on their pinnate tentacles. Pinnate meaning
So
it
you'll
has a
probably
lot
be
of
feeling that
side
move pretty
branches
soon if you haven't
on
already.
those
Yeah.
tentacles,
It's
just like the
started,
crinoid above it has pinnate arms.
All right, let's come on out.
So we're currently making our way up to the top of this cone feature on Wagner Seamount. We want to make good time so that we can characterize the summit of this cone. We're hoping that there'll be a denser biological community near the top. Coming into center screen, it looks to be a dead stalk. And below it, a nematocarcinous shrimp.
Got some welding operations in the wind shrimp. Don't be advised, flashing lights on your monitors.
Lots of these black corals.
So I'm seeing something pink coming into center screen.
Yeah.
Is that a dike?
I don't know what that
On
is.
video?
And the video feed too. We should take a look at that.
Oh, I see that. We'll look at that feature next.
Don't think it's geologic. Yes. Yeah, you're right. Yeah, now I can see.
What is it?
It's a crack.
Oh.
In the-
Filled with sediment.
Yeah, it was.
I thought it was projecting upwards.
Yeah, it was. So in video feed 2, the Sirius view, there's the interesting crack in the lava flows with sediment in between. It was kind of confusing us a little bit.
And what we're looking at now in video feed 1 looks to be a plurobranch, or a type of mollusk.
Probably right at about
So
the end of that move.
plurobranchs are like nudibranchs, but they have their gills on the inside, whereas nudibranchs have their gills on the outside. So the gills are their breathing
okay with another
appendages.
So how does it work having gills on the inside? What's the advantage there? Seems like it'd be harder to breathe.
It might be, but they can pump water through their body just like way snails and other mollusks
These
do.
20-meter moves are working pretty nice.
Maybe it keeps them cleaner.
Yeah, well, and it can protect their breathing appendages.
Mm-hmm.
Some corals we haven't seen before. Here. Potentially.
So I'm seeing some more stauropathes, chrysogorgid bottlebrush coral, likely chrysogorgid geniculata, and then right behind that, an anthomastus, or soft coral, mushroom coral. So there's a little associate on the branches of this chrysogorgid coral. Looks to be Europtychus, a type of squat lobster. You almost always see this type of squat lobster perched in the branches of chrysogorgid corals.
But they don't eat the coral, right? They wait for other prey to come in?
Yeah, that's right. They don't eat the coral. This is their home. And so they feed on other prey as it comes along.
Any interest in the other corals in this area?
Can we zoom on this little amphipod or isopod?
We're at max zoom.
I think it might be an isopod.
This is Tom Hansconnett. What I think it is, I think it's a parasitic isopod, and he's intermittently feeding on fish. It could be an eagity.
Eagity?
Yeah, as opposed to a sinusoid. The eyes are larger, but you really have to be able to look at the dactyl eye to see if they're prehensile to separate them.
Well, that would be a hard zoom for us to get. So I guess to really identify this would be to have a specimen in hand.
Would a
Yeah,
different
but
angle
the size
help?
of the eyes indicates eagle.
Okay, cool.
That's interesting. I mean, it's waiting for a fish or something to parasitize, and then it'll feed, and then drop
What
off.
just happened?
I lost my high monitor.
So it must have just finished eating, or is just waiting for its next meal
just
to come
turned off.
along.
Yeah, went into power save.
Lost signal.
Yeah, you saw them on other dives on grenadiers.
Maybe it came in on a sleep or something.
So the rat tail fishes.
Yeah, but it's not a specific. It's not an obligate parasite. It's the intermittent one.
Video whenever you're happy.
got you at 61.
That's really interesting.
Probably settling out from that move, so no rush. But.
This is sea star here. Look at that. Going back to the sea star.
So I think I'm seeing a sponge on the far in the distance on the left-hand side, and just numerous of these
Snapped in on this.
Stauropathes corals. And now we're looking at a starfish.
Sliding down.
From this angle, I cannot tell what it is. That's really, it sort of has these spines along the upper face of the arms. I don't think I've seen this starfish before. Hopefully Chris Ma will see it soon and have something to say about it.
I don't think I've seen that one.
Very interesting. Everything I see is interesting.
Crawling along the surface.
That's the great thing about doing these types of dives is we almost always see something new, and
Okay, now.
I love being stumped by organisms that I don't know.
Something crawling along
Yeah.
the surface here.
Moving like an inchworm.
Yeah.
Hey, Megan.
Hey, Chris.
Yes.
Good to hear your voice. This
Good.
is a very interesting animal you're looking at.
Let-
Is it possible to get
No, we're all stopped
a
right
different angle to look at the top?
Sure, let me ask the pilot. Pilot, is it,
Thank you.
can we look at it from another angle, perhaps?
Yeah, I think we could do that. Come on out, video.
So have we seen something like this before, Chris?
The closest thing that I could kind of pin a name to is
Repeat,
it
just
looks
Tether
like a
looks happy.
Zoroasterid. But the other Zoroastrids that I've seen never have spines
Trying to
that
make it
are
like a
this
17
distinct.
Watch.
I mean,
Yeah, see it go between 20 and 15.
they're big.
Put,
Usually
yeah,
Zoroaster
I got that
itself
square pretty high up,
is
so it should be fine.
the species or the genus that we see. It's usually much bigger, and it has spines, but they're not. They're prominent and they form an even ridge. But this one really has
Trying to get above it.
extremely distinct, almost like a series of like needles on the surface, and that is really.
All right, come on back in.
I mean, part of me could just sort of write it off as being, oh, it's another species of Zoroaster, or maybe it's a smaller one, but it's a really bizarre-looking one.
Yeah, that's what I was thinking.
Scott France said that we may not have ever seen one of these in the entire 3 years of the capstone expeditions. So it is apparently seconded or thirded as far as it being unique.
I'm going to try to adjust lights. I think it's pretty good lighting. But
If you think you can improve
Wow.
it, go ahead.
It is, okay, it's a Zoroasterid. It may even be Zoroaster. It might be a small individual of those big orange ones that we typically see. I think the species that we were calling spinulosus. I didn't catch the size. Are the lasers on, or are we too close?
Yeah, I think we're too close for the lasers, but we'll zoom out and see how large this is. I think it looks relatively small.
we just have a small
Okay.
subject.
Keep coming out.
Because one of the weird things about echinoderms is that they will often develop certain characters first, and then, oh, I see, so it's meters.
Few inches across.
Yeah,
So
maybe
it is relatively small. I'm going.
Kevin, go back in.
That's well. Okay, so basically, sometimes echinoderms have characteristics that become very large very quickly, and then the animal catches up in terms of its growth later on. and I think this is probably just Zoroaster spinulosus. But again, one of the weird Zoroaster that we see, the big orange one with the really large spines, it might change color and just grow up to match the other characteristics later on. It's like I said earlier, it's got something weird about the way that the spines are arranged, though. So
is this something we would want to collect at all, or not necessarily?
I think this might be a difficult collection given its location.
Yeah, I'm not 100% on collecting this one. I mean, if it was the last thing you saw just before you had to leave the bottom, then and everybody was dying, and it was already on a rock, then sure. But yeah, I'd say there are other things that are worthwhile. This is an interesting discovery, to be sure. But I think I could go with calling this a juvenile Zoroaster spinulosus, the one that we've seen on the dives. They're not as common. It's not as common. They're not very commonly encountered. And like I said, the ones that we have seen, especially from the last couple of legs, are orange instead of white. But that could change with growth, or it could simply change with the kind of food that they eat. But yeah, the spines are really something strange. I'll have to look into them. A lot of times these animals, when they're collected in museums, the characteristics, such as the spines, are broken off just almost always, and because they're in trawl nets, and the surface characteristics, such as the spines, are just completely shorn off. They're brought up in a net, they're dragged for 3 or 4 hours along the bottom, and then they're brought up to the top, and then they're bumped around. So it could just be that it's just very, very unrecognizable compared to the specimens known in museums. So
all right,
it's an interesting observation at the very least. So I'll definitely be poring over that a little bit later. I see you're on a sponge now, so have fun, and I'll be watching. Thank you. Thanks, Megan and John.
And now we're looking at a glass sponge.
Megan, you're muted.
Oh, that. Now we're looking at a glass sponge. So I think this might be Sacocalix. It's a type of stalk sponge in the family Euplectellidae, so a glass sponge.
It's coming tight on some of the texture.
Sacocalix is pretty recognizable by its surface texture. It looks like it has these sort of lobes along the outside and this open osculum on the top, so that large opening that we're looking down into right now. So sponges have a lot of very unique words to describe parts of the sponge, like osculum and atrial surface, dermal surface. So it's really hard for non-sponge taxonomists to get the handle of all these different words, but they really do help us describe what we're looking at and have other people understand what we're seeing. So your word of the day is osculum.
Push forward.
Sounds good.
It's a black coral directly behind it.
Okay, I think
If we just tip up, tilt up.
All right. Oh, you're right. It's different.
We have a black
bridge.
coral here.
Oh, this is a different black coral than we've
I
seen
just
so
wanted
far.
to give you a conditions update. It looks like our wind has
This
increased.
might
It's holding
be
around 20
Umbellapathes.
right now. The ship is still
But
holding
let's
nicely,
see
but
if
I want to let you
anybody
know.
on
Good
the
copy,
line
thank you.
knows.
You're welcome.
Tina Molitsova is going to chime in soon.
Coming tight on. Let's look at the base of the branch.
So Scott French is saying Umbellapathes as well. So I'm going to have to count out how many different types of black corals we've seen. We've seen quite a few. Heteropathes, stauropathes, alternatipathes, umbellapathes. And you'll notice that all of these black corals end with pathes.
Why is that?
I know Scott knows why. Could you explain for us, Scott, either in the chat or if you could call in? I just know that they all end in pathes. I think it's something based on a Greek word, but I'd have to do some Googling to find that out.
Hey, pilot, co-pilot, why don't you guys switch?
So a lot of times we name organisms to help describe what they look like or some sort of character that they might have or behavior that they exhibit. So right now we're going through a pilot change. And then on this rock behind our Sacocalix, I see a different kind of
I'm gonna
black
go ahead and
coral,
call in that move too,
possibly a
so one of the
Bathopathes.
tracks upslope.
Yep. That's
Bridge, this is Nav.
250.
Go ahead, Nav.
Can we get a move of 20 meters bearing 250 at 0.2 knots?
20 meters during 250, speed decimal 2 coming up.
Correct,
So
thanks.
Scott's telling me on the chat log that the name of this group is Anthopathes, which means against disease. And it was thought that the skeleton of black corals had medicinal properties some 2,000 years ago.
RV Nav Bridge, move of 20 meters bearing 250, speed decimal 2 initiated.
Thanks, Bridge.
Line back up again.
There was interest in that crack earlier.
So I'm seeing a sea pen settled in the sediment in this large crack. What do you call large cracks in geology terms?
Fractures.
Fractures.
Get lasers. Good ride.
And now that we learn more about octocorals and their properties, some anthropotherians have been found to have medicinal properties and have been used in the development of certain drugs.
Good video with your
So
famous
even though maybe 2,000 years ago they thought it had medicinal properties, but the way that they were applying them may not have been as effective, perhaps a lot of these corals do have medicinal properties. And that's one of the reasons why we need to study the deep sea. So this is a sea pen, and it's anchored in the sediment.
Not a lot of contrast on this one because of the white sand, but if you have any more zoom videos, go for it. It's hard to see the polyps.
So this might be a Productylum, or in the genus Productylum. And I'm basing that off of the way that the polyps are branching off this main axis of the coral. And how it's settled down into a sedimented area. That's a beautiful shot.
Looks like it has small little nubs along the stalk or the stem or the
Yeah, that's quite interesting.
bumps, small
Any
bumps.
more zoom video? Or is that full?
Now I am seeing that same feature on one of our gallery images, but this seems a little bit more pronounced.
Right. Slow rotate.
I think we're good for science on this one.
Okay, video near clear. Come wide. Keep moving up.
So if you're just joining us, this is Megan Putz, your biology lead.
And John Smith, your geology lead.
We're coming to you live from the Okeanos Explorer. We are currently exploring up in the Musicians Seamounts, which is a seamount chain north of Hawaii. Today we're diving on Wagner Seamount. All of these seamounts in the Musicians Seamount chain are named after famous composers. We are currently at a depth of 2,396 meters and looking for some interesting biology and geology today.
Yeah, maybe it might be just the start of it.
So right now, coming into view, we're seeing a Walteria sponge, or a glass sponge, in the genus Walteria.
Move just about complete.
Thanks, Bridge.
And I think another kind of black coral right next to it.
Zoom in a little bit for the video. Yeah.
And a fish on the left.
And a fish.
Into the center.
I'm going to acquire fish here.
Bruce, do you think this might be a synaptobranchid eel or an ophidiid? Let's see.
It's probably enough with lasers.
I think this is a synaptobranchid, we call it. It's a longer-bodied animal than most of the ophidiids. It's the shape of the tail that we see gives it away. This is an arrow-toothed eel in the subfamily Iliopinae. It's got a more rounded snout and a kind of underslung jaw. The cutthroat eels have a lower jaw that projects out as much as the upper jaw. This one doesn't have the distinctive white lateral line pores that we see in a lot of these Iliopinae eels. It's probably the genus Iliopus. That shaking behavior is a typical response to the presence of the ROV that we see in synaptobranchid eels. It's being disturbed by the light, the noise, and the vibration. Okay, now we can see the white lateral line pores, those lines of dots along the middle of the body. Those are sensory pores for detecting vibrations and water movement. There's that stereotypical reaction again. So this is an arrow-toothed eel in the family Synaptobranchidae in genus Iliopus.
I think I would shake my head like that if someone shined bright lights in my face, too.
Take a little more zoom video if you got it. Of course. Every time.
So, Pilot, next I'd like to see that black coral that was next to the Walteria sponge, that long sponge.
Okay, video when you're clear, come wide. Acquire black coral should be here.
Getting your lasers back on while you
So this looks like be yet another genus of black coral.
The darker one?
Yeah, that orange-looking one, the tall one. And behind it is also another black coral, Umbellapathes, that we looked at just a little while ago.
Okay, just 1 second, and then we can zoom in. Okay, video, go ahead and frame this one up. Okay.
These black corals have always been pretty tricky to me. Trying to decide what I might want to guess what this is. Could be, I don't know. A Parantipathes, perhaps? So Scott French is also saying Parantipathes. Tina, do you have any opinions about this particular black coral? Tina Molitsova is saying Heteropathes.
Yeah, probably about at the end of that move.
Yeah, I think I'm stopping here.
And behind this coral, we're also seeing an Umbellapathes. They sort of look like umbrellas. That's how I remember the name of that coral.
Yeah, I was kind of using that too.
And then there is a shrimp inside this sponge. So oftentimes we see shrimps trapped inside these Walteria sponges. They likely go in there for shelter as young juveniles, and then they get too big and can't get out. So this one looks to be a female. It has eggs in its pleopods. And here's another fun science word for you. When a shrimp has eggs like this, we say that it is gravid, or holding eggs.
Okay, watch these. Do you want a closer look at anything else in this area? Else I can continue on.
If we have a little more zoom, it would be great to see if we can see the cheilipeds on the shrimp, and then we're also seeing some amphipods perched along the branches above the shrimp.
Okay, video, do you have more zoom?
So
That's
cheilipeds are the claws of the shrimp.
That's max zoom, watch lead.
All right. Thank you, pilot. I think we're good here.
Okay. All right, video. Any other shots you want, or? Okay. Sounds good.
It just seems like some Caribbean
Down
shrimp,
at 70.
not an
I think
althea.
I've stopped.
A Caridian shrimp?
Yeah.
I see nothing ahead. I think we can probably do another move.
Well, let's wait till
Now
it gets out
coming
a little
into
bit.
view, I'm seeing a sea cucumber, likely in the family Synallactidae.
Okay, video,
The
clear that.
Synallactids are pretty typical
coming in.
with having this sort of pinkish,
That's a
purplish
partial view.
coloration,
Okay, hold it.
but they also come in white and variable colors as well.
Get rid of this laser spray.
And oftentimes we
Yeah,
see
no
these
lasers,
fleshy
video coming in.
projections
Okay,
along the
coming in.
body.
I have more
This
zoom
one
too.
seems to have a lot of little bumps.
Yeah, we'll hold zoom here unless the.
Sounds good.
Are these the same as the bright purple ones we've seen?
They're in the same family as the bright purple ones that we've seen, but likely not the same genus.
Oh, it is. Okay. Okay.
So I can't really go much further on this than the family.
Do I need to stop anything?
But
on the side?
hopefully
Okay.
some sea cucumber experts will help us identify these animals better.
I'll make a note of it.
Thank you, pilot. We're good for science here.
Excellent. Video, when you're clear, we can
Okay,
zoom out.
coming out.
Keep moving up. Thank you, video.
There we go.
And that's ROV CTD.
Oh, I think I might see a primnoid coral. Center screen
Yeah,
on the bottom.
White one. Go by, can you grab lasers as I settle in just to get the size of this guy?
So primnoid corals are typically white, and when we
Hey,
zoom
video.
in, we'll be able to see the
zoom in on
polyps
this
of this
3400
coral.
km.
Coming in.
To identify a primnoid coral, we're looking for body scales along the main axis of the polyp itself.
Okay, video, if you have more zoom, you can take it.
Okay.
Kind of sand background, not a lot of contrast, but let's see what we
So on this coral, I think I'm seeing at least 3 body scales, putting this coral in the genus Norella. So this is a primnoid coral in the genus Norella.
Sorry, video.
It's okay.
I'll get you a stable shot here eventually.
There we go.
This is the first Pronoa coral we've seen today, but yesterday we saw a dense community of Pronoa corals lined up all along an outcrop.
Yeah, they were pretty impressive. And they were most all Primnoas, I guess, on that one rock face.
And there must have been some sort of settling event or reproductive event that allowed them all to settle in the same location.
That's
Yeah, they were all about the same size.
Likely the same age.
There you go.
Right, when you're done here, I'll put
So,
another
talking
move in.
about age, a lot of these
push
deep
ahead.
sea corals and sponges go at very, very slow
You're still looking at
rates.
250 Copilot.
So we have just begun to study how fast these corals grow and how fast a community can recover after a disturbance event.
Okay, coming out.
All right.
Okay, that's full wide.
Bridge, this is Nav.
Go ahead, Matt.
Another ship move, please.
Sure.
20 meters, bearing 250 at 0.2 knots.
That's 20 meters, bearing 250, speed decimal 2.
That's correct. Thank you.
Video, let's frame this little guy up.
Now coming into view will be a sea urchin. This looks to be sea urchin in the family Aspidodiadematidae, likely genus Aspidodiadema.
Okay, video, you can take more zoom.
Okay, coming in.
And on the top of this urchin, you'll see this sort of bump. And you can see its little 2 feet moving the urchin along. It's actually moving pretty fast.
Yeah, it looks like he's going for some of that green flocculent material there that's on the bottom.
It's likely relatively tasty.
Maybe to him.
Perhaps. So the mouth of this urchin is actually on the underside, so it doesn't really have to do too much to be able to feed on this flocculent material, as you say. I also love how it just moves straight into our camera view, perfectly lining itself up for its beauty shot.
And
so to identify these urchins, we're looking at these little bumps that the spines are coming out of and seeing if they're lined up, and that's typical of Aspidodiadema. Thank you, pilot.
Okay, video when you're clear.
I don't think we've seen too many urchins on this cruise so far, have we?
Not too much. I think we have seen one Aspidodiadema.
That's
we saw one large purple pancake urchin.
Still another minute or two before series starts moving. But
I agree.
Might want to push ahead. Erratic ping there on the USBL.
That's not.
That wasn't so bad.
Actually, it cleared, didn't it?
All right.
It's interesting that
It looks to be like we've got some more chrysogorgic corals, another synallactid, sea cucumber. We just saw one of those. Looks to be about the same one, very light pink in color. There's an interesting sponge coming up on the right.
Yeah, that's what I was going for with the sponge.
Yay, a sponge.
Yay, a sponge. And then a gastropod on the rock, perhaps?
The orange guy?
Yeah, that orange one. Let's look at the sponge first, and then...
Stop your starboard couple.
This looks
I'm watching it tight. I'm gonna
very
keep
odd.
where it is.
Like a vase that got a lump in it.
yeah, lump in its throat.
Okay, video, let's frame this up.
Okay.
kind of got my body shape
in
these
perfect.
days, doesn't it?
I wasn't going to say anything. What is this sponge?
Trying to work that out. So this is Chris Kelly calling in from the University of Hawaii,
Coming
and
in.
this is the vase sponge.
I still have more Zoom.
Glass sponge. Spicules made of silica or microscopic parts. Kind of a curious one here. I think it's a euplectellid vase, but the actual structure there is very different. Megan, have you seen any others that kind of look like these channels and osculum arrangement on your cruise so far? I don't think I've seen this before.
I haven't seen this before.
Bridge, let's bring the ship to an easy stop here.
Roger, easy stop.
How far
And
to
on the, it looks like on the opposite side.
Which is informative. They just,
RV-Nav
they
Bridge,
just
we're
pan
actually
down, and that's
pretty
great.
much on
That's
site
what they
right
call basicide attachment.
Gotcha, that's fine, thanks.
Okay.
And then the water on these sponges, the water enters into the sides of the sponge here where they're zooming in, and through these holes and pores, the water is filtered inside the tissue of the sponge, and then the X current of the water, after it's been filtered, collects in a central cavity called an atrium, and then it comes out the top, exits the sponge.
Would
You
this?
got some biological samples so far?
No, we haven't collected anything yet. Do you think this would be a good candidate for collection?
These ridges are very curious for typical euplectellid sponges. I just am not sure I've ever seen this arrangement before.
Yeah, they're
If you
very.
don't have a collection already and you haven't seen that many animals, I think you potentially have something new here. In fact, it wouldn't surprise me at all. I do suspect you have something new, or at least a new record.
I'll just call it back 15.
Okay, Chris. Yeah, I think we will go ahead with a collection here, pilot.
Okay, coming wide.
Copy that.
Bridge, this is Nav.
Okay, that's full wide.
Yeah, we'd like to reverse the ship, so we're going to go 15 meters, bearing 070
And on the opposite side,
at
Chris, it
0
looked like it
decimal,
had some sort of
2
globes
knots.
coming off of it when we zoomed into the base.
That's correct.
Yeah, I saw that. So the two most common vase sponges we see down here are in the genus Dictyalis and the genus Regadrella. There are some other ones. There's some that attach to fibrous attachment, Euplectella. And then there's Corbitella, which I haven't really documented very well, so I'm kind of wondering whether this could potentially be in the genus Corbitella. In fact, I don't think we've ever collected one of those out here that's been confirmed.
And it doesn't have
So
that
it is really
sieve plate on
unusual.
top like Dictyalis and Regadrella usually do.
Yeah, oh, very good. That's right. Thank you, Megan. That just totally escaped me. So it's lacking that sieve plate, that grating right on the top of the hole, which makes it even more unusual. Wow.
Yeah.
And there might actually be something inside, some animals living inside those little darker spots.
Yeah, I was wondering if that was something on the outside of the sponge or inside. I didn't see anything outside when we zoomed. So maybe we'll get some associates along with this collection. Looks to be maybe a foot tall. Should we try to collect the whole thing?
Well, that's always really useful. That's preferable because the actual microscopic parts can change from the base to the top. And if it's a new species, which I think it definitely could be, to be able to describe it, it's really helpful to have the whole set of spicules for the sponge.
Well, actually, pilot.
Go ahead, pilot.
Do they want to try to pluck it from the base or kind of cut it near the base?
I think we should try to pluck it from the base.
Okay. Copy.
Chris, do you think it'll come away from the rock relatively easily if we try to just pluck it?
I suspect it could be a soft sponge, but I'm not positive. If it's brittle, it'll just hit a crack right when you grab at the bottom. If you can grab it below that, yeah, down in there somewhere. But even if it's a soft sponge, you should be able to tear it off. You might leave a little bit of the base attached. There's nothing you can do about that. Because they glue themselves on pretty hard onto these rocks. Wow, this is terrific.
Yeah, we're back 5 meters from
gonna have to do some homework here.
Strip a few more meters. So.
You'll have lots of sponging to do.
On the right monitor. Send that up.
Thanks, Rich.
You're welcome.
Give me Zeus on the right monitor, please. Yeah, just so
So I get a lot of help. So once we've got images from these sponges, and I go onto the FTP site and download the images the next day. Then we've got Dr. Konstantin Tabachnik at the Shirshov Institute in Moscow, and also Dr. Henry Reiswig in Vancouver, and Dr. Martin Dorman in Germany, and I usually send them all pictures.
It looks pretty soft.
Oh.
They just tapped it.
It is attached to a rock that is loose, but together they're too big.
Yeah, but I don't think that rock will fit in our bio box.
Yeah, exactly.
So, you might want to practice kind of feathering in as you close the jaw.
I was going to go for a full close. Sure.
Force that.
4. Force 4. Am I going to hit the rocks? Hit the floaters. I think I'm going to cut it pretty close to here. Box you got ready for me?
I got both port ready for you.
Excellent. So I'm pretty sure that's a soft sponge by the way it behaved when you grabbed it, and it wouldn't surprise me if you've got some associates. Whoops. There it goes.
It's floating down.
Okay.
Well, that gives you a good view of
I'm gonna take your other
the texture on the opposite side that I was talking about.
I'm going to try it. Try to get a small amount of time to decide here. I think it's going to drift. If it settles down there, I might be able to cradle it back up, but if it blows under the RV, then I probably won't be able to get that.
Oh no.
It blew away.
Oh no, it blew away.
Well, you still have part of the base up there.
I'm going to bring your cameras back up.
It was very soft. That was, well, we did learn something about it.
Okay, watch these. So I could try to cradle some of what remains from, scratch some of that off the rock. I might have some in the jaws right now, like DNA. But not much in the jaws at all.
Oh, I don't really see anything in the jaws.
Yeah, I don't see much either.
So, Chris, should we try to grab this last little bit on the rock here?
Well, we could, but is the current ripping so... I mean, wouldn't it just be right underneath the ROV if you took a look, or is the current ripping enough to really take it away?
Yeah, well, it drifted right underneath the ROV, so if we took off, it probably would just spiral away somewhere.
Yeah.
Or if you want this base, we should grab it before we move and look for it.
I don't think it's going to fit.
We could try the base, and if we...
Could you put that rock in the bio box that has the base on it? Because
No,
you might have the same thing happen if you try to grab the smaller piece.
I think it's too big for the bio box. That was the initial problem.
Yeah. I think the rock's too big for the bio box. We could try to get some of it off the rock, and then after that we could go look for the remains.
Yeah, I guess you could. Yeah, maybe we can just take a quick peek and see if it's there.
Yeah, well, we watched it float underneath the rock boxes on the ROV.
Got plenty of altitude.
All right, let's go for the base.
Yeah, we go for the base.
But we'll try to back up and see if we can find it. Well, that's you. Can you hear me?
Oh.
The shrimp is there, not even moving.
Yeah, shrimp.
Shrimp is not phased by claw of death.
It is pretty amazing that it's not even phased by what's happening right next to him.
The intelligence of crustaceans.
Right.
Well, the sponge looks extremely fragile.
Yeah.
Oh no! It just
I
disintegrated.
think it's yeah. I was trying to pry the rock up a little bit to a position where I could grab it.
Well, I can. That pretty much rules out Regadrella, that genus, because Regadrella would hold up much better than that. It's got sort of partial silicification of the spicules. So that gives us a clue that, again, it's not fitting into that genus. And I think it's way too fragile to be Dictyalis either.
Yeah, both of those seem pretty robust.
Do cradle. Okay, watch late. I think we can try to look and see if the large bulb section is below me.
Okay.
And then if it is, we can go for that. But else, I don't think I'll be able to get.
And I would.
Yeah,
if we can,
if we grab it, if we see it, then let's do that. But
yeah.
If it's looking too gone, then we'll just move on.
Absolutely.
Yeah. Maybe we'll see another one.
If you can, try to position the ROV so that you can open the
I
drawer
agree,
without moving.
and even if you don't find it, thanks for trying.
No, I don't see it.
Yeah, judging by how fast it was kind of blowing past me, my guess would be kind of tumbled downhill. I think I might see
got some space to come back. The ship is seriously settled out now, so there it is.
Oh, there it is.
Hey.
Just floating there. Got caught in a little by a rock.
It's trying to disguise itself as a sea cucumber.
It does kind of look like a sea cucumber.
It does.
It's gonna be a tough one. I don't know if I'm able to drawer. Yeah, you understand?
I think you could come down a little more, Dave.
So an interesting thing about these vase sponges, people have been watching the Okeanos certainly heard me tell this story before, but there is speculation that this type of design with a vase and a larger opening up on the top allows the sponge to utilize a Venturi effect and actually draw water through the body wall at a faster, more efficient route. Kind of like blowing over the top of a Coke bottle or something, where you're pulling air outside of the Coke bottle from inside. Similarly, the water current passing over this large opening sucks water from the main cavity, which then pulls water into the body of the sponge at a faster rate than would normally go through it. So one of the fascinating things
That's a
that,
test. I can't believe
aspects that I really like of
I have to
sponges
maneuver the
are
vehicle
their different
in a critical
morphologies
situation
and
in
how
case
they're
one happens.
solving problems with filtering the water
fair.
current in the most efficient manner. And there are obviously a lot of solutions to that problem. We see this with corals, where you can be branching upright, have a lyrate structure, you can have tubes, all types of different ways to do it. But this is a fascinating way, if
Could
that's true.
rotate.
And they're very difficult to
kinda
really
thinking that.
understand what's
You might
happening
try
because
it.
they're so
It might
deep, of course. You can't really
Disintegrate, but
do very much experimentation with live material because
there's
it's so
the
hard to
stop.
keep these in laboratories. Obviously, bring them up in good shape when they're coming from
I
a
think you could
totally
get it,
different environment
with that amount
tons of
open.
pressure and so forth, and freezing cold temperatures.
I'd go.
Anyway, just thought I would throw out that little nugget while we're waiting for the attempt to grab it.
It's tough.
That's an interesting
I would probably go for the
speculation,
cradle.
Chris.
I think so too. I also really like how a number of different
Forster's a good
animals
choice.
have, developed a similar strategy to dealing with this current problem,
feather
even
it in
independently of each other.
Trying to just get a little bit of force, but not too much.
Yeah, exactly. And the corals down here, they all are kind of oriented sideways, not like the reef corals up in shallow water that are photosynthetic. In that case, a lot of their morphology is based on exposing as much surface area to the light, the downwelling light. But down here, they're not photosynthetic. So they actually get all their food and energy from what's coming laterally, carried through by the currents. So that's why you get a lot of fan shapes down here in bushes and things like that. So these tube sponges also are really great because the current can change directions completely, and it doesn't matter. They have a cylindrical shape, so they can filter from any direction efficiently.
All right.
It's like a little beach ball.
Being very careful not to cut it in half.
Oh.
You're gonna have to get a little bit of force on it. Yeah, right there. Slowly, slowly. Watch your grip.
Beautiful.
Yeah, he can get it in there. Close your fingers and push it in. Be careful, that camera's right there.
So the current
This sponge is not cooperating.
is like a sail. It's in the skid. Okay.
I have to let it go.
It was half in the box, and then the current kind of blew it out of the box.
Oh man.
Yeah. Close the drawer. I don't think we're going to be able to get this one watch leads.
All right. Well, that was a really good attempt. Maybe part of it will get stuck in the ROV and stay there. Unlikely.
Yeah, thanks for trying, guys.
Hydraulic secure.
Well, sometimes that happens, folks. You can't always get a sample. But, you know, there's always something better over the next pill of lava.
All right, let's get
or
centered
sheet
back up.
flow.
Get another move in.
Maybe we'll see this same sponge again and be able to try it a second attempt of collecting it. But if not, we did get some really great imagery of this sponge, so hopefully that'll help us in understanding a little bit more about it.
Why don't you line back up at 250, Dave?
So right now we're at a depth of 2,394 meters. We're making our way to the top of a cone feature on Wagner Seamount in the Musicians Seamounts. This is your biology lead, Megan Putz, coming to you live from the Okeanos Explorer.
I'm going to go ahead and call the move in as you get lined up. Bridge, this is Nav.
Go ahead, Nav.
Yeah, we'd like 20 meters, bearing 250 at 0.2 knots.
That is 20 meters, bearing 250, speed decimal 2.
That's correct. Thanks.
I think I see a fish there, Megan. You see it coming in the center right now?
A fish. I do not see a fish.
Good. Video, go and zoom in a little bit.
Oh, there it is. It's a
It's
halosaur.
about to go off screen at the bottom of the camera.
Good frame it up video.
It blended into the rock just enough.
Good eye.
ROV nav bridge move of 20 meters, bearing 250, speed decimal 2.
So
initiated.
right now
Thanks,
we're
Bridge.
looking at a holosaur, and there are two genuses that I know of, Aldrovandia and Holosaurus. To tell the difference between these two genuses, we need to see the top of its nose, see if there are scales there or not. Aldrovandia does not have scales, while Holosaurus
yeah,
does. So I think I'm seeing scales on the top of its nose, which means that is in the genus Holosaurus.
Come back in. Right, drift through.
I really love these fish. They look sort of like little eel-like dragons of the deep sea.
Okay, video, you're clear. We're good on